Earth is heating up faster than ever before. From scorching heat waves to rising oceans, our planet is giving us warning after warning. The Paris Agreement aimed to keep global temperature rise below 1.5 degrees Celsius. But guess what? We're not on track. What if we told you scientists are working on ways to pull carbon directly out of the sky? Today, we're diving deep into 3 revolutionary methods to cool the Earth by removing CO2 from our atmosphere, from high-tech machines to ocean chemistry experiments. Let's explore the science, the politics, the challenges, and the promises behind these carbon removal strategies. Direct air capture, or DAC, is like installing a massive vacuum cleaner in the atmosphere. These machines literally suck CO2 out of thin air, filter it, compress it, and either bury it underground or use it in products like concrete. One of the biggest projects is launching in West Texas, a $1 billion venture between Occidental Petroleum and Carbon Engineering from Canada. It aims to capture 500,000 tons of CO2 annually. But there's a catch. It's super expensive, around $600 to $1,000 per ton. That's nearly 10 times the going rate for carbon credits in the EU. Still, companies like Microsoft and Google are already investing, and the U.S. Department of Energy pledged over $1.2 billion to support DAC hubs, one in Texas, another in Louisiana. Now, with Trump back in office, these projects are in limbo. Funding is frozen. Thousands of clean tech employees fired. The future of DAC in America? Uncertain. Imagine this. You pour antacid into the ocean, and suddenly the seawater can absorb more carbon. That's exactly what scientists in Massachusetts are about to do in a $10 million project called Loch Ness. This isn't fantasy, it's chemistry. By adding sodium hydroxide, they're slightly increasing the ocean's alkalinity, making it a better carbon sink. The experiment will happen about 60 kilometers off Provincetown. 50 tons of solution will be released and tracked using autonomous drones and tracer dyes. Scientists will watch how CO2 absorption increases and how marine life reacts. If scaled up globally, this method could absorb up to 1 billion tons of CO2 each year, about the same as Japan's annual emissions. Early models suggest minimal negative impact, but experiments like Loch Ness are critical to confirm that. One major concern is how changing ocean chemistry might affect plankton and shell-building organisms. The simplest way to remove carbon? Trees. But trees can burn, be chopped down, or die, making them unreliable for permanent carbon removal. That's why Europe is pushing BECCS bioenergy with carbon capture and storage. Here's how it works. 1. Burn organic material like wood chips. 2. Capture the carbon emissions. 3. Bury that carbon deep underground. Sounds promising, right? But BECCS comes with its own challenges: land use, high cost, and a need for long-term monitoring. And despite hundreds of startups jumping in, there's still no global standard for how carbon removal should be measured, verified, or priced. Critics warn that carbon removal is being hyped as a silver bullet, allowing governments and corporations to delay emissions cuts. Worse, the market is fragmented, unregulated, a Wild West, as one policy expert called it. The government could play a critical role in establishing standards, but those efforts are being swept away. With the carbon negative shot, a major U.S. initiative, now on pause, scientists worry the tech won't advance quickly enough to make a real difference. So where do we go from here? Governments must recommit to funding and regulation. Private sector must demand transparency in carbon credit markets. Scientists need more real-world data to test these technologies. And citizens, like you and me, must keep the pressure on leaders to take action. Whether it's pulling carbon from the sky, the sea, or the soil, one thing's clear: climate repair isn't optional anymore. The technologies exist, the urgency is real. The only question is, will we act in time? If you found this video helpful, don't forget to like, subscribe, and share. Drop a comment. Which carbon removal strategy do you think has the most promise? Let's keep the conversation and the solutions moving forward.